Welcome to the next session on real numbers. We'll be proceeding with the sums in exercise 1.2. In the last session, we did up to the first subdivision of question number 2. We'll continue with the second subdivision. Okay, we have to use the prime factorization method and find the LCM and HCF of these two numbers. Okay, shall we try? Yes, be ready. 510. Then we are, because 0 ending, we can divide by 2. It is 25 times, and then 2 and 0, 5 times. Now obviously this is divisible by 3. 5 plus 5, 10 plus 2, 12. So it is 8 times and then 5 times. Then we have to divide by 5. Then 17 times, and then 17 being a prime number. This is how it is factors. Okay, now 510 we write it as 2 into 3 into 5 into 17 into 1. Okay. Now we have to factorize 92. So how do we factorize 92? 2 ending. So definitely it is divisible by 2. Therefore 4 times, 6 times. Again it is 2 ending, 6 ending. Therefore we get 23 here, and 23 is a prime number. So beyond which we cannot factorize. Therefore I write 92 as 2 into 2 into 23 into 1. Your prime factorization is over. Next we have to choose the HCF. Now look at these two factorization. Only one time 2 is common for both. Therefore I just circle this 2. Okay, and then 2 is the HCF. And 1 and 2 are the only common factors, and out of that 2 is the bigger number. Therefore, we can justify taking HCF as the number 2. Okay. Now, coming to LCM. Now, here the 2, how many powers? It's only 1 power common, but the maximum power here is 2. Therefore, while choosing the LCM, we have to take 2 powers of 2. That is the maximum power. That is the way we should proceed. And apart from that, there are from here 3, and from here 5, and then there is one 17, and there is one 23. So we have to choose into 5, into 17, into 23 as the LCM of these numbers. Got it? So you have to be very careful in choosing the LCM. 2 powers of 2, maximum power of 2, that is the common factor is 2. Therefore, I am writing 2 square. Then apart from that, 1, 2, 3, 3, 5 and 17, and here from here 23. They are all common. They are all to be multiplied to get the common multiple. Correct? So let us see how does it multiply. 2 to the power 4, then 12, 60. So 17 into 23 into 60 is the LCM. First I will multiply this 17 and 23. You will get the required answer. 3 17s are 51 and 2 17s are 34. Then multiplying will get 391. Now here we can again multiply by 60, you will get 6, 54, 5 carry over, 3, 6 are 18 plus 5, 23. So 23,460 is the LCM of these two numbers. So this is how you should finish. The next sum, children, this is subdivision 3. Now first let us take 336. You divide by 2 because it is 6 ending. We will get that is 16 times 168, and then divide 8 times 2, 84. Then again divide by 2, it is 42, and then divide by 2, it is 21, and then 3, and then here 7, and then 7, 1. Okay, are you understanding? Therefore, I can write this factorization as 336 is equal to 1, 2, 3, 4. 4 powers of 2 into 3 into 7 into, of course, this one. But this one makes sense. Why we are not omitting 1? When there is no common factor, we can circle on 1 and say the HCF is 1. Therefore, I insist that you should write that 1 also. Okay. Now, go to 54 and then we can, this is the number 4. Therefore, we can divide by 2 and then this cannot be divided by 2. Therefore, I can take 3 as the next dividing factor and then this again 3 times, then again this again 1 time. Therefore, I have got 54 factorized as 2 into 3 into 3 into 3. Now tell me how to choose the common factors. So here there are 4 powers of 2. But here there is only 1 power of 2. And here there is a 3, here also 3. Therefore, 1 power of 3 is common. And also 1 power of 2 is common. Correct? Therefore, we take the HCF as but the product of 2 and 3, which is 6, is the HCF. Are you understanding? Is it clear to you? The common factors you should take and then multiply the common factors, you will get the HCF. Now for the LCM, how do we choose? Here the 2, 3, 3, 7. So for 2, we have got the maximum power as 2 power 4. Therefore, for getting the LCM, we should take the 4 powers of 2. And in addition to that, there is 1, 3. The maximum power for both is only 1. Here 3 powers, but common is only 1. But we are taking the highest power. There are 3 powers. So we will get 2 power 3 into, there is 1 7 also. So multiplied here, you will get the LCM. Okay. Now, of course, no other factors left out. Therefore, we can take. Okay. Now, here we multiply. 2 power of 4 is equal to 16. Correct? 16 into 3 power 3. What is 3 power 3? 3 into 3 into 3, that is 27. So what do we do? 16 into 27 into 7 is the LCM. So first we will multiply these two. We know that 7 16s are 112 and then 2 16s are 32. I write here 2 4 3 2. Are you getting it correctly? You check your multiplication once again. It is 4 3 2. Okay, so 16 7s 112 and then 16 2s 32 multiplied by 7. That gives you 3024. Therefore, the LCM is equal to 3024. We have to finish like this. Let us move on to the third sum. The first subdivision, find the HCF and LCM of 2, 5 and 21. So, now 2 is a prime number and doesn't have any other factor except 1. Therefore, we write 2 as 2 into 1. And 15 can be factorized as 5 into 3. That's all. No other prime factors. And 21 is also a composite number, which is nothing but 3 7s are. Now, if you look at that, so what is the common factor for all the 3? 3 is common only for these two, but 3 is not common here. Therefore, we write HCF as 1. Is that clear to you? Are you understanding? Now, coming to the LCM, so we will write 2. And then, from this common factor for 3, there is only 1 power of 3 which is common here. Therefore, we write 3. And then there is 2 we have written, the 3 also we have written, and apart from that there are 2 more factors, namely 5 and 7. If you multiply, that becomes the LCM of these two numbers. Are you understanding? Shall we find out? So it is 2 5s are 10 into 3 7s are 21. So 210. Now I want to have a look at the second sum. 17 is a prime number. Therefore it is only, it can be broken like this. 17 into 1. And 23 is again a prime number. 23 into 1. And then 29, if you take, that is also a prime number. So for all the 3 prime numbers, 1 is the common factor. Therefore, HCF is equal to 1. And coming to the LCM, what is the LCM? No common factor for all the three, therefore the product is the LCM. So 17 into 23 into 29 is the LCM. First you multiply these two and find out, and with that you multiply the third number. So if you multiply, it is 3 17s 51 and 2 17s 34, you will get 391. And 391 you multiply by 9, 29. So first is 9, 9 9s are 81, 8 carry over, 3 9s are 27 plus 8, 3, 5. Then 2 times, and then 8, 7, 8, and then 9 here. So 11,339 is the LCM. So we will write here HCF is equal to 1 and LCM is equal to 11,339. We have to finish like that. So two things you have understood. If you have to find the HCF of the three prime numbers, it is always 1 because we cannot find any common factor. Just because there is no common factor, the product itself is their LCM. Are you understanding? That's what we found out in this sum. We'll move on to the third. Let us move on to the third subdivision, 8, 9 and 25. 8, 9 and 25. Now first let us break this number. 8 is equal to, we all know it is 2 power 3. So we can easily write down as 2 into 2 into 2 into 1. Okay. Now 9. 9 is obviously 3 into 3. Yes, you are ready with the answer. Wonderful. And then 25. 25 is 5 into 5 into 1. Now look at all the three numbers. 8, 9, 25. All the three numbers are composite numbers. But still they don't have any common factor. Is there any common factor for these two numbers and three numbers? Except one. They don't have any other common factor. Therefore, we have to choose the HCF as 1 only. Now, they don't have common factor. So, what is the rule? What we applied for the previous sum, the multiplication of 8 into 9 into 25 is the LCM. That is the product of all the three numbers. So, we all know this is 72 multiplied by 25. Then this is 5 2s are 10. If you know the 725 table, you apply or you multiply 2 times, nothing wrong. 360, 2 2s are 4, 2 7s are 14. Now if you write, once again you check whether your answer is right. Therefore the LCM is equal to 1800 and HCF is equal to 1 is the right answer. Correct? So you practice more sums like this. This is definitely going to improve your multiplication table skills. And again you are revisiting your factors and multiples chapter which you have studied in your earlier classes. So you practice few more sums and then perfect it. Tomorrow or the next session we will move on to the next concept. Thank you children. Wish you all the best.